All right, so situation A, the student claims, if you read Marta's claim, she says that the rule 5x, 5y will make a character that is similar to Mug, but the rule 5xy will not produce a character similar to Mug. This statement is in fact true. You could have gone through the process of actually drawing this out and creating coordinate points and things to see that this in fact would be different. But hopefully after looking at these rules, you will see that in order to get a completely scaled, factored, appropriately picture of the original Mug Wump, you have to multiply both x and y by the same number. If you look at Lug and Glug, the imposters, this one we only multiplied one of the coordinates, and this one here we multiplied the other coordinate by a number. So the fact that we didn't multiply both x and y by the same value, that is going to create an imposter. So Marta's claim is in fact true. If we move over to Jacob, Jacob's claim says that he can use the coordinate rule to predict how the corresponding side lengths compare between Mug and a similar Wump. This is also in fact true. If we look again at the examples that you guys did, the fact that Zug is 2x, 2y, I know if I take a side length or a part somewhere of this Mug Wump, or I'm sorry, this Zug Wump, let's look at like the top of his head. If I count the distance from this tip of his head to this tip, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units long. Now remember, we got that though because we had multiplied x and y by 2. So if this should work, I should cut that 8 in half, which would give me 4, and that should be the length of the top of his head over here, which if you count, 1, 2, 3, 4, that in fact actually does work. And so you could repeat that process, but this number here will tell us, it'll help us identify then how many times longer those side lengths would be. Same thing for Bug. The fact that this is 3x, 3y, I know that these are lengths that are all triple in size, and you could also go through the process of counting those. The next claim was from Zach. Zach stated that for similar figures, the measures of the corresponding angles change the same way as the corresponding side lengths. This one is in fact false. Yesterday, or actually a couple days ago, we discussed that angles do not change, okay, in order for it to be similar. If you look, actually comparing Zug here, if you pull an angle from maybe up here, or you can look at one of these angles over here and look at what matches on the other particular Wump family member, you will see that the fact that these are different is because those are not similar to even begin with. However, if you look at from Zug to Bug, this angle measure here, if we were to pull out a protractor, you guys can use those benchmark estimating angles. These two angles here would correspond and they would be the exact same degree measure. The last one is Billy. Billy's claim says that the rule XY creates a figure that is exactly the same as the original. This is in fact true as well. XY is the original coordinate rule to begin with, so it is in fact going to create an exact same replica of the original figure. Situation B, new rules. It said to make a rule that would create a figure similar to Lug. Lug, if you remember, had the rule of 3x and y. Now, if I want it to be similar to this, I need to be using this rule. So don't get confused. We don't want to go back to Mug Wump, right? We're talking about Lug here. So I want to take this image, or I'm sorry, yes, I guess this would be an image, and we're going to now call it the actual original picture, and we're going to multiply, and it has to be by the same number, right? It can't be one or the other. I'm not going to write 3x, 3y, because that's not what we're doing. That would create Bug over here, if you remember 3x, 3y, but the fact that I want to make something similar to this. So an easy one is to double. So if I wanted to create something that was double, I could in fact change this to 6x, because 3x plus 3x would give me 6x, or 3x times 2 would give me 6x, and then the other one would become 3y. And so the fact that these numbers here are just simply doubled this original coordinate rule, that means these two are in fact going to be similar. I could have done the same thing also by tripling it. 3x would become 9x, and then y would become 3y. And I just realized I made an error. Did you guys catch it? This, in fact, was not 3y. That would have been 2y because we doubled it. So be careful. The last part then, describe how the corresponding angle measures and side lengths change. Well, again, angles. Key point, angles never change. We want to make sure that we understand that those will not change no matter how that scale factor is applied. The side lengths are going to depend on what you ended up doing here. The fact that I doubled them in the first example or tripled them in the third example, and maybe some of you guys even wanted to go a little more creative. We haven't done this yet, but you could have actually made them smaller as well. So that can be an option as well. A little trickier of an idea, but some of you in class could probably handle that. So something like that could be, let's say I divided them both by 3. I could have that as x and then y over 3 because you just have one y, but really that's the coefficient of 1/3. You would probably see it like that. Multiplying by 1/3 is the same as dividing by 3. So that's a little spicier, but hopefully you got the idea with these two up here.